Hello, today we are talking about dilution of solutions part 1. For Arabic video, see the link in the description below. هذا الفيديو مسجل بالإنجليزية، رابط الفيديو بالعربية موجود في الوصف. To talk about dilution of solutions and to understand the concepts of dilution, first we should understand what the term of dilution means. Dilution is the process by which the concentration or activity of a given solution is decreased by the addition of solvent or diluent. In general, any solution composes of two parts. The solute, which means the substance to be dissolved, and the solvent, the dissolving substance. The dilution represents the ratio of a concentrated or stock solution or the volume to be diluted to the final volume. If we consider the sample or the reagent or the solution to be diluted as a stock or concentrated one, so we can express the dilution as the formula, the ratio between volume to be diluted to the or over the total or the final volume, which is the volume after dilution. So the volume to be diluted, it should be the numerator of the fraction or this ratio, and the total volume or the final volume, which is the sum of sample volume and diluent volume, should be the denominator of the fraction or ratio. There are two types of dilution, the simple dilution, which means one-step dilution, and the serial dilution, which means multiple-step dilution, multiplicative or progressive dilution. According to Beers-Lambert law, as the concentration of solution increases, the color intensity increases, so the light absorbance increases as well. So, with regard to the definition of dilution, the concentration decreases as the dilution increases, and so the color of solution will be lighter and lighter, so the color intensity decreases along with the increase of dilution. So the dilution increases, the concentration decreases along with the dilution, the color intensity of the diluted solution decreases as well. Here, suppose that you have added a spoon of salt, table salt, NaCl, to a certain volume of water. For example, 100 ml of water. So the NaCl here has a concentration. If you added more solvent or more diluent, more distilled water to the spoon of salt, so the concentration will decrease. What the mean of concentration decreases? Here in this beaker, a spoon of NaCl to 100 ml of water, it means that higher concentration, it's mean distribution, more distribution of the solute over the liquid. If you added more water to reach 250 ml, this means that NaCl molecules will distribute to a larger volume. This is how the concentration decreases. In either cases, the amount of NaCl is the same. The spoon of NaCl here is the spoon of NaCl here. The amount not changed, but the distribution, so the concentration, it changed. This leads us to a clue how can we deal with simple dilution or the one-step dilution. We said the amount of NaCl not changed. This can be expressed by the equation number of moles before dilution equal number of moles after dilution. The amount of NaCl here is equal to the amount of NaCl here. But the distribution, so as the concentration between the two beakers, just different. Number of moles before dilution equal number of moles after dilution, which means the concentration, the initial concentration of the solution multiplied by the volume to be diluted equals the final concentration multiplied by the final volume. Here an example. To make 30 ml of 10% solution from 90% solution, calculate the initial volume and the volume of diluent. First, you should ask yourself, what is the final volume? The final volume is usually comes after to make. So we want to make finally 30 ml of solution. So the final volume is 30. What is the initial concentration? We have defined the dilution as the dilution progress, the concentration decreases. So the initial concentration should be the higher. This means 90% solution or 90%, this is the initial concentration, and 10%, this is the final concentration. By applying the equation of dilution, the initial volume is unknown. So by doing calculation, the initial volume equals 3.33 ml. So to make 30 ml of a diluted solution, you should take 3.33 ml from the concentrated solution and continue or complete till 30 ml of diluent. So the volume of diluent calculated as subtracting the final volume from the initial volume, which means 26.6 ml. Another example, how to make 8 ml of 1 in 20 dilution of a blood. You should ask yourself, what does 1 in 20 mean? 1 in 20 means that the final concentration will be 20 times lower than the initial concentration. So the higher concentration, the initial is 20, and the final concentration, the lower is 1. So let's apply the dilution equation. So here we applied the equation. The initial volume equals 0.4 ml. So this dilution can be made by taking 0.4 ml of a blood sample and to complete till 8 ml of the diluent or solvent. To apply the dilution formula or calculating the dilution, here an example, calculate the dilution of a blood when using 60 microliter of a blood and 120 microliter of diluting fluid. So you should remember that the dilution equals the ratio between volume to be diluted to the total or final volume. So if we want to apply this formula, so the dilution equals the volume to be diluted, which means 60 microliter of a blood over the summation of, or the sum of 60 of a blood and plus 120 of the diluent, which means 60 over 180. This equals 1/3. There is a term called dilution factor, which defined as the reciprocal of dilution. So dilution factor formula, the total final volume over the volume to be diluted. So the dilution inversed or reciprocal. So as we said, the dilution factor is the reciprocal of dilution or the dilution inverse, which means the total final volume will be the numerator and the volume to be diluted will be the denominator. Serial dilution involves multiple dilution tubes through multiple steps, not one step, at which the concentration decreases gradually by successive dilution. So it involves multiple progressive dilution ranging from the higher or the concentrated solution to less concentrated solution. So the serial dilution, it's any dilution at which the concentration decreases, and some serial dilution in some serial dilutions, the concentration decreases by the same quantity in each successive step. This figure explains the serial dilution. Here a sample to be analyzed. A certain volume, 100 microliter, transferred to the first tube that contains certain volume of the diluent, and then 10 microliter transferred to the second tube that also contain a certain volume of diluent, and then a 12 microliter from tube 2 transferred to a tube 3 that also contain a diluent. The total dilution at the final of this serial dilution is the product of each dilution in each tube in the series. So the total dilution or the final dilution is the dilution of tube 1 multiplied by the dilution of tube 2 multiplied with the dilution of tube 3. For example, the sample to be analyzed has been diluted as the following: 100 microliter transferred to 100 microliter diluent containing a tube, and then 10 microliter of tube 1 transferred to 990 microliter of the diluent containing a tube 2, and then 12 microliter from tube 2 transferred to tube 3 that contain 288 microliter of diluent. So if we want to calculate the dilution of tube 1, so if we want to apply the formula of dilution, the volume to be diluted from the sample, which means 100 over the sum of total volume, the sum of sample volume and diluent volume, which means 100 plus 100. This equals 100 there. 200 equals 1/2. The dilution of a tube 2 can be calculated as the following. The volume to be diluted, here 10 microliter taken from tube 1, 10 microliter divided by the 10 microliter plus 990 microliter, which equals 10 over 1000. This means 1 over 100. Here, the tube diluted 100 times from a tube 1 that diluted half time from the original sample. So we can't say the dilution of tube 2 is 1 over 100 and stop as it. So we should mention that the dilution, the final dilution of a tube 2 should be 1/2 multiplied by 1 over 100, which means 1 over 200. According to tube 3, diluted as the following: 12 microliter of from tube 2 transferred to 288. So the total volume will be 12 plus 288, which means 12 over 300. This means that the dilution of tube 3 1/25 from tube 2. So this one this 1 over 25 should be multiplied by 1 over 200, which equals 1 over 5,000. The final dilution, it can be calculated by either the dilution of each tube, 1/2 multiplied by 1 over 100 multiplied by 1 over 25, or calculated by as the dilution of the third tube as the following. So it will be considered as here 1 over 5,000, and the dilution factor, we said that it's the reciprocal of dilution, so the dilution factor will be 5,000. Another example, unknown solution has been diluted as the following: 10 microliter of the original solution transferred to tube containing 990 microliter of diluent. After mixing, 10 microliter from tube 1 transferred to the same amount of diluent in another tube, and then after mixing, 10 microliter transferred to from the second tube transferred to the third tube that contain also 990 microliter of diluent. This is how the dilution and the concentration, the dilution increases and the concentration decreases by the same quantity in each successive step. The sentence that has been mentioned in slide 9. Here we said sometimes the concentration decreases by the same quantity in each successive step. Simply by applying the formula of dilution. Here, the dilution of a tube 1 will be calculated as the following: 10 over 1000, which equal 1 over 100. Also, the dilution of a tube 2 will be 1 over 100, but 1 over 100 from the previous tube. So the dilution will be 1 over 100 multiplied by also 1 over 100, which means 1 over 10,000 or 10 to the power plus 4. So 10 to the power minus 4. Tube 3 also diluted as 1 over 100 from tube 2. So the dilution will be 1 over 1 million, which means 10 to the power minus 6. This will be the final dilution here, and the dilution factor will be 1 million. In this example, a solution or undiluted sample contain 50,000 cells per ml as a concentration, as the original concentration, have been diluted to three tubes. The first dilution performed as the following: 1 ml from the original transferred to 9 ml of distilled water. This means that the first dilution will be 1 to 10. 1/10 or 1 over 10. Then the second dilution of tube 2 will be 1/2 multiplied by 1/10, which means 1/20th or 1 over 20. Dilution 3 can be calculated as the following: over 10, 2 over 10 multiplied by 1 over 20, 1/5, multiplied by 1/20th, so the final dilution is the dilution of the last tube, or the product of the dilution of each tube, and the dilution factor is 100. Here, tube 1 concentration is requested. So the original concentration is 50,000 cell per ml. The tube 1 concentration can be calculated as the following: the product or the multiplication of the original concentration by the dilution of tube 1. So the product of original concentration and the dilution of what tube? Of tube 1, the requested. Which equals 5,000 cells per ml. Suppose that the original or stick solution concentration is unknown. As a concentration, the concentration is unknown and has been diluted as the following: 1 ml of this original or the sample transferred to tube contain 9 ml water, and then 1 ml of tube 1 transferred to tube 2 that contain also 9 ml of water, the same from tube 2 to the tube 3, and the same from tube 3 to tube 4. So the dilution will be for tube 1 here 1 to 10 or 1 over 10. Here 1 over 100. Each tube as a separate has a dilution 1 over 10, but as a successive, the tube dilution should be multiplied with its previous. So this will be 1 over 1000, and the tube 4 will be 1 over 10,000, and this is the final dilution, and dilution factor will be the reciprocal of total dilution, which means 10,000. If a dilution factor requested, it should be calculated from the reciprocal of the final or the total dilution, which means either the product of each tube dilution or the dilution of the last tube. If dilution factor for any tube has been requested, so should be the reciprocal of the tube dilution. So if I asked about the dilution factor for tube 1, so it should be 10, and dilution factor for tube 2 should be 100, 1000, 10,000. The original concentration can be calculated by the following formula: a tube concentration multiplied by dilution factor of the tube. So here the concentration of each tube has been calculated or given. If I take tube 1 to calculate, so the original concentration can be calculated by 10 molar multiplied by 10, the dilution factor of a tube 1 of the same tube, 10 multiplied by 10, 100, which means here I have hidden the original concentration, 100 molar. 1 molar tube concentration of tube 2, and dilution factor of a tube 2, 101 multiplied by 100, it's 100 molar. And the same, 0.1 molar multiplied by 1000, it yield 100 molar, and the same for tube 4. So it should to be applied by this tube concentration multiplied by the dilution factor of the same tube that use its concentration. Here, the original concentration can be calculated by multiplying the tube concentration by its dilution factor. And the tube concentration can be calculated by multiplying the original concentration by a tube dilution. So here I can calculate the concentration of a tube 2 and the concentration of a tube 3 as the same of what I did of tube 1 concentration. I can use the original concentration multiplied by the dilution of tube 2. So the dilution of tube 2 1/20th should be multiplied by 50,000, and then we can get the concentration of tube 2. Here 1/100 should be multiplied by the original concentration to get the concentration of the third tube. This is the end of this lecture. Your comments are welcome, and your suggestions, questions also are welcome, and put it in the comments, please. Thank you.